And finally what we'll have is the total, means in the array will be there solution array. In that the indices will be there 1993, 1994. In that indices how many times it's repeated, that many counts will be there, like we are doing plus plus here, right? So that much incremented counts will be there. Then we'll be finding out in that array which is the maximum count we have. That index, the count, the maximum count index will return the earliest year. The earlier we get, the earlier will return. Okay. So here what we are doing, we are starting from 1950 to 2050. Why we are starting from 1950? That's because the constraints are given here from 1950 to 2050 only. You have to consider. Okay. So we'll be starting from here and ending here. In between we are checking if solution of I means the value at index I, like in 1950 year how many counts were there, 1951 how many were there, it's greater than max. If it's greater, max will become that solution value. Okay. And j will be becoming I, means j will store the value which we have. Okay. Means the index which they will basically show the year. Okay, since 1950 is there, suppose that in 1950 like a population was 7. Okay, that's the max value, suppose. So solution of I, which is 1950, that will be greater than max. Max will become solution, and which index we got the maximum value, 1950, that will be stored in j. So j will have the year in which the maximum population was there. Like that we will do till 2050, and whichever index will get the maximum value, that index value will be stored in j, which is nothing but the year, and that will be returning here. Okay, so let's try to run this program and see. So here it's showing success. Okay, so let's move on to the next one. In this question what we have been given is determine whether the matrix can be obtained by rotation. Suppose that a matrix n cross n is given to us which has ones and zeros. So we have been given with two matrices. Okay, mat and target. Okay, return true if it's possible to make mat equal to target by rotating mat in 90-degree increments. Okay, false otherwise. Now for that what are you doing? Suppose that you have a card here with you, and in that card it's written 0 1 and here 1 0. If you rotate this card like this, okay, if you flip it like this, what will be the what will be shown in your card? It will be shown like the 0 1 will be here, and then I mean 1 0 will be here because of this one, and when you rotate this row here like this, it will become 0 1. Now when we do in the first iteration only, we'll get the answer. So therefore it is true. Let's consider another example. 0 1 1 1. Here three ones are there, but here only two 1 is there. So no matter how many times you rotate, you will not get this array. At that time, you return false. Okay. And here what will return is, suppose that this is the mat array and this is the target array. How can you obtain by rotation? When if this is your card, if you rotate this card, 0 0 0 will come here, 0 1 0 will come here, and 1 1 1 will come here. Again you rotate, this will come in the top, this will be in the middle row, and this will be in the least column. So therefore we have by conversion means two times if you rotate, the target array is reached. Okay. So this is the mainly the question. So I have found a very nice explanation solution. So this is the code here, and this is the solution. Okay, explanation is here. So let's go through the code and see the explanation as well. So as you can see, three times you can rotate, right? First 90-degree, then 180-degree, then 270, then 270, then finally 360 means the same location. So we are just rotating three times. So I'll run from 0 to means less than 4 means three times it will iterate. So this loop is just for the iteration purpose. Okay. Inside that what we'll check is if arrays are equal, means mat and target are equal, return as true. Remember we have to return a boolean value. So therefore if the arrays became equal, return as true. If it's not, then do the following. First we'll calculate the length. Length means in our case, suppose that this is the array here. In this array what is the length? The length is 3, right? So there will have as 3 in length, and what it does is int first is equal to 0, first is less than length by 2, first plus plus. What is 3 by 2? It's 1. So first is less than 1. Okay, first is less than 1 means it will always go from 0 to 1, right? So when it goes from 0 to 1, what will happen? Each time what we'll do, we'll access the element. Okay, j is first, j is less than last, j plus plus. Okay, and we have offset here which is j minus first, This will understand when we look at an example. The explanation is like this. Okay, by using the offset and the j values, what we are basically doing is we are in the first iteration 1 2 3 4 should come here, 1 2 3 4 5 6 7 8 should come here, 19 11 10 should come here, 13 14 15 and 16 should come here. Okay, when we rotate by 90, how can this be achieved? One thing you can observe carefully is 1 4 16 and 13. If you shift 1 here and 4 here and 16 here and 13 here, you'll get this thing here 13 1 4 and 16. Next, do the same thing for 2 8 and 15 and 9. Okay, when you do that, we'll get here 9 will come here and 2 will come here, 8 will come here and 15 will come here. Same thing for 3 also, 3 12 14 and 5. Okay, so 14 from here it will come here. Okay, 5 from here it will go here. Okay, and then 3 will come here and then 12 will come here. After that, finally what we have is the 4 is already done, so 3 times rotation will give us this value. Okay, 1 is done, 2 is done, 3 is done. Okay, means 4 was there because of 1, so we will not make any change to that. Okay, so basically 3 times rotation gave us this result. Until how much we rotated? We rotated till n by 2, right? The total length was 4. What is 4 by 2? 2. So index value is 0, 1, 2. Till this point only we rotated, right? So this is the main thing which we are doing here. This is just for the exchange purpose. The top corner element of this one will come here. This will come in this position. This will come here, and this will come here. And how to get this location back? We'll store in a temporary variable top. Okay, that will store the first location. Then we will override these locations here one by one, and finally we'll place here the top element which was stored initially. Okay. So this is the code for it. Let's try to run this code and see. So this is basically the concept. On running this code, it shows as success. So you can use this code. Okay. Let's move to the next one.